Okay, so question 1 is all about will it break? Part 2. So let's go through what happened. It boiled down to that we analyzed that for our I-beam, we needed to just look at 0.15 meters width. If I stand on it, that the bending stress, should be sufficient such that the maximum stress that we're going to get is going to be less than the tensile strength of the polystyrene. So we analyzed the problem. Is the free body diagram. It's me in the middle, 982 newtons, and the two reaction points either side. So I drew a shear force diagram, 491 newtons, minus 491 newtons. Got a width of 0.075 meters. So this area is going to be all I need to find for the bending moment value. So remember that the bending moment value is the integral of the shear force diagram. So in symbols, that's m is the integral of q with respect to delta x. So it's that area there. That area there is relatively straightforward to find. That's just going to be the 0.075 times by the 491. So it gives me a bending moment of 37 Newton meters. So the finding the centroid is straightforward because my beam is just an I-beam, so it's bang in the center, but you can check it if you want. So we can take our AY values, sum them all up, divide them by our A values, and we do get indeed the value of the centroid bang in the middle. For my H values then, since this is going to be at 10 and that's going to be at 30, H value will be 20. The one in the middle will be 0 because it's in the middle. And the H value from here to here will also be 20. So put in your H values and then you're ready to do your AH squareds, and of course you've already got your B's and your D's to find your BD's to the power 3 divided by 12s. So you can find out all your second moment of area terms for the standard results and for the parallel access theorem results. Add all these together and you end up with the second moment of area for the I-beam shape of 1.05 times 10 to the minus 6 meters to the power 4. Now what I was curious about was obviously this isn't something we cover in the first year. You're going to get more stress around these corners. And when I examined the fracture that was occurred last week, it was indeed coming at a corner. So I thought to myself, oh, I better check this. So I'm going to make a solid beam now with no sharp corners. Now if we notice for the second moment of area for this particular case, all we need to do to find the second moment of area for this is quite straightforward. It's just going to be BD to the power 3 divided by 12. It's got the same width and the same height as my other section. And what's quite surprising that this second moment of area virtually is the same. I mean, these numbers are virtually both 1 times 10 to the minus 6, 1 times 10 to the minus 6. Relatively small difference. So I'll basically treat them both as 1 times 10 to the minus 6 for any further calculations. So now I can do my bending stress calculation. What's that going to be? So I'll use this formula here, the bending moment times by the Y max value, which will be that'll be 30 millimeters, won't it? And then we got the 1 times 10 to the minus 6 meters to the power 4 there. So put in our numbers, 37, 30 times 10 to the minus 3, 1 times 10 to the minus 6, and we roughly get 1 megapascals. So that bending stress will be roughly the same as the tensile strength for the polystyrene. Okay, So well, that will give us a factor safety 1. So we examined this in the lectorial, and what I did was for the last week I tried standing on that particular I-beam, and it snapped like a twig. So our results, I had my dumbbells with me, so my results were for my 3 kilogram dumbbells, we ended up with a factor of safety 30, and it was fine. The I-beam was happy. And if I stood on it, we had a factor of safety of 1, and it snapped like a twig. So for part 2, what we did was do some further tests. Got some other weights from Dan. So I got a 10 kilogram, a 20 kilogram, 30 kilogram, and see what would happen there. So if we loaded it up with these, so we're going from factor safety of 9, 5, 3, and we know from the previous week that it failed at factor safety 1. So we know that that one fails. So would the factor of safety 9 be okay, or factor safety 5, factor safety 3? So here's me taking my first 10 kilogram. Gonna put it on my I-beam, and yeah, it's happy I-beam there, so it's not bending. I'm gonna put another one on, yeah, and there we go. So we're happy there. We're now at factor safety 5, and gonna put another one on, and it's still happy. So there we go. Now let's go for the square beam. Okay, so the square beam, we're gonna put, I'm gonna stand on it. So the factor of safety will be 1, because our I is virtually the same. It's virtually the same as this case. So let's see what happens. So this is the point to stop the video and make a decision. When I put my total weight on it, what will happen? Once you've just made a decision, press play. It snaps like a twig again. There we go. So that's my story for question 1. Hope you enjoyed it. Did you get it right? So yeah, the point is that the stress factors around the corners still weren't causing an issue. We could load this beam to factor safety 3, but when we try at factor safety 1, still snaps.